Welcome to Brain Vision.
So first we express the stored energy U in terms of the charge on the capacitor. So that is equal to Q square over 2C, and this equation is equation 24.5 in the textbook. And the charge Q can be given can be the charge Q on the capacitor is given by equation 26.6a, and according to that this is equal to C times EMF times 1 minus e to the power t over tau. Now we plug this value of charge in this equation. So we have U equal to 1 over 2 C times Q square. So that is C times EMF 1 minus t, 1 minus e to the power minus t over tau. We have to take a whole square of that. And this simplifies to 1 over C EMF square 1 minus e to the power minus t over tau square. And this part is the maximum potential energy, because this is so this part is the maximum potential energy, because if you want to verify that, so let's say this is U, and at t equals to 0, so this part just becomes 1 at t equals to 0, and that at that point we get the maximum potential energy, and that comes out to be half C square of the EMF. So this part, let's write that as maximum potential energy. So, and we know that U, so let me just write the same equation again. So we got U equal to U max 1 minus e to the power t over tau square. And we know that U at time t is 0.75 U max, which is basically 75% of the maximum potential energy. Repeat what the terms U and U max mean over here. So U is the potential energy at a particular time t, and U max is the maximum potential energy which we get at t equals to 0, because according to this equation the potential energy keeps exponentially decreasing with time. So the only way to get the maximum potential energy if we calculate the potential at t equals to 0. So that's what we do, and we find U max to be half C square of the EMF, and we plug U max in place of this expression. Now, since we are given U equal to 0.75 of U max, so we plug this value over here to find the time it takes to reach this potential energy. So let's do that. Now, the thing that I like about this equation is U max basically cancels out. So we don't need to find U max in order to find the time it takes to reach a potential energy that is some percentage of the maximum potential energy. So now we have 1 minus e to the power minus t over tau square equal to 0.75. So let me just go to the next page in order to solve that. So we get 1 minus e to the power minus t over tau will be square root of 0.75. So e to the power minus t over tau will be 1 minus square root of 0.75. And we take ln on both sides. So we get minus t over tau to be equal to ln 1 minus 0.75 root 2. And time t will then be equal to negative time constant times ln of 1 minus root over 0.75. And if we solve this part, we get t equal to uh, 2.01 tau. So this value will be a negative value, but there is already negative sign here, so negative times negative becomes positive, and that becomes 2.01. So the time is 2.01 time constant. So this is the time taken or needed in order for the potential energy to reach 75% of the maximum potential energy.